Alright, so for frequency data, we can figure out the standard deviation. There is a specialized formula for figuring out the standard deviation of frequency data. You can see it's this one here. Again, I'm not going to be using that because I'm just going to be using the calculator. In order to enter this data into the calculator, it is a little bit different though, so I'll walk you through that process. We're going to start off by clearing off list 1 rather. And I'll enter my values into L1, so 2, 4, 6, 8, 10. And I'm actually going to enter my frequencies into L2, so 3, 8, 9, 6, 1. So we have L1 is the actual values, L2 is the frequencies. So the value 2 is occurring 3 times, the value 4 is occurring 8 times, and so on. Now, the way I tell my calculator to actually take this into account, if I go into Calc and just run one of our stats like this, it's just going to look at L1, and it doesn't know that L2 is involved. So what I need to do is I need to tell it to act on L1. I can tell I got L1 here by pressing second and then the number 1 here. You can see in yellow above 1 is L1. And then I'll do comma L2. That's in yellow above the number 2. So I'll press second and that one. That gives me comma L2. Depending on your calculator, even other graphing calculators will ask for this a slightly different way. They'll probably give you a value list and then a frequency list. In your value list, you should just leave L1 where it is, and in your frequency list, you should say L2. So you'll go ahead and do that. It can be kind of hard to tell if it actually used the frequency list, but you can see my n is 27. If it hadn't taken my frequency list into account, I would expect my n to be 5, because there would be 5 different values. But since since the n is 27, that should be equal to 3 plus 8 plus 9 plus 6 plus 1. Let's see, that's 10, that's 24, that's 27. Yeah, okay, so those do sum up to 27. So I verified it actually did take my frequency list into account. But now I can figure out, this actually tells you your frequency mean. It tells you your frequency standard deviation. Your mean and your standard deviation, just the same. So find the mean and the standard deviation for this data. The mean is, that almost looks like an alpha, backwards alpha or something. Equals 5.5 repeating, and your standard deviation here is 2.1. What percent of the values are within one standard deviation of the mean? We're going to do the same thing as what we did before. I'll do 5.5 repeating minus 2.1. So this means they need to be between 3.455 and, I guess I don't need the bar over that. Nothing. These are all integers anyway. The sum of these. 7.655. Alright, so which values are between 3.455 and 7.655? Let's see, those ones and those ones, 8 are too high, which means we have 17 of the 27 values are within one standard deviation of the mean, which gives us approximately 0.62. 96. What percent are within 0.6 standard deviations of the mean? Same sort of thing. We need to figure out, we're going to do our mean plus or minus 0.6 times the standard deviation. So let me pull this line back up here. I'll do this times 0.6 to figure out our mean minus 0.6 times our standard deviation. So this will be 4.2955. And them added together instead of subtracted. 6.81. Alright, so let's look to see which are in that range. And it looks like here we only have the 6s. The 4s are too small, because the 4s are less than 4.2 whatever. So it looks like we only have 9 of the 27 which is equal to 0.3 repeating, I suppose. So as you get, you know, if you're talking only taking a smaller portion of the standard deviation, of course you have less values within one standard deviation of the mean.